So a lot from 7-3 should be familiar, but then there's some of these are going to cause you some issues. So we're going to go through a select few together. So some additional colors would be handy. And maybe even a highlighter. All right, so I'm going to start off with number 3. So number 3 is a fraction on the right, and then we have the S. Listen, boys. Jack, can you turn all the way around? There we go. And I'm solving for R. R is in the denominator. So when you have a situation where you have a fraction on one side and then one term on the other side, just one term, if I were you, I would make this one term into a proportion by putting that S over 1. Because I can break up the fractions by looking at it as a proportion and cross-multiplying. So write a note to yourself, make into a proportion. And so then we can cross-multiply the S to the R and the V to the 1. So S times R is SR. 1 times V is V. What am I solving for? R. So if I want R by itself, how do you undo what's happening to R and S? Yeah, it's being multiplied, so you're going to divide not by R but by S, right? Because I'm solving for R. The S's cancel, and my final answer, you can't leave it that way. You have to actually write out your final answer. R is equal to V over S. Then an additional thing that we're going to do that you haven't done before is look at this answer. Which variable cannot equal a certain number and why? S can't be 0. Why? Yeah, the denominator of a fraction can't be 0. So one more thing they have to add is that S cannot equal 0. That's a restriction. So when it says state the restrictions, that's what I'm referring to. So anytime you see a fraction, look at the denominator and set that denominator equal to 0. Can equal 0. So if I set S equal to 0, S cannot equal 0. Alright, then we're going to look at number 6. This time I'm solving for T. So this is the variable term that has T in it. So whatever term or terms have T in them, you want to get them on one side by themselves. So I want to get rid of, I want that by itself, I want to get rid of P. How do you get rid of P? Everybody, how do you get rid of P? Well, what's happening between P and this term? Addition. How do you undo addition? So we should be subtracting P. And make sure that if you have a capital P, you keep it capital. There is a big difference between capital letters and lowercase letters. So you have to keep them in their proper upper or lowercase. So I end up with A minus P equals PRT. So my focus is still on T. What's happening to P and R and T? They're being multiplied, so how do you undo multiplication? So I'm going to divide this whole side by PR and this whole side by PR. So the P's and the R's cancel. And I'm going to write T is equal to A minus P all over PR. Are there any restrictions? P, what value would P have to be to make the denominator 0? 0, right? So P cannot equal 0. And what value would R have to be to make the denominator 0? 0 also. So I'm going to put a P comma R. Neither one of those can equal 0. Then look at 9. So what's difficult about 9? There's a fraction, right? And what we're solving for is outside the fraction, so that's okay. But if I were you, I'd get rid of the fraction first. How have I taught you how to get rid of a fraction? Don't multiply by the reciprocal, multiply by what? The denominator. What's the denominator? 2. So I'm going to multiply the left by 2 and this right side by 2. Don't the 2's here cancel? Right? And so I end up with 2a equals h times a plus b. Now you're going to be dying to distribute that h. Don't distribute, because we're trying to solve for h, right? Don't distribute the h. If I'm trying to solve for it, what's happening to the h and this a plus b? Being multiplied by a plus b, right? So how do you undo that? If I divide this whole side and I'm going to use parentheses by a plus b, won't the a plus b's cancel? So then I have to divide this side by a plus b. So I'm going to do use the symmetric property, and I've got h is equal to 2a over a plus b. Now, the restrictions on this are a little bit more tricky. Set a plus b not equal to 0, right? Because we don't want that whole denominator to be 0. So when you have two variables in the denominator, you have two different answers. Let's solve this equation, even though it's a not equal. Solve it for a. What would you have to do? We'd have to subtract b. And so wouldn't we end up with a cannot equal negative b? Would you agree that if a and b are opposite signs, because that's what it's saying, right? If they're opposite signs, will we have 0? Yeah. The only time that a and b will cause the denominator to be 0 is if they are exactly the same number, but opposite signs. And that's what this is saying here. A cannot be the opposite of b. So that's a more difficult restriction. All right, then I'm going to look at 10. What am I solving for? N. And what's a problem here? You got that fraction again, right? So this is why I say don't get rid of the fraction by multiplying by the reciprocal. What are you going to multiply by?
2.
Yep, just 2, or 2 on the left and 2 over 1 on the right, because that's a fraction, the left is not. So on the right, the 2's cancel. I have 2s equals an n times a plus l. Make your l's cursive, otherwise they look like 1's. So now how are you going to solve for n? And tell me, which problem is this just like now? Isn't it just like number 9? So you write down how you're going to solve for n, what you think you'll do. So what'd you do? Are you with me? I haven't written down a single thing in this problem. So what'd you do? What'd you do to both sides? If n is being multiplied by a plus l, how do you undo multiplying? Dividing by what? A plus l. So that's what I did to both sides. I divided both sides by a plus l. Make sure your l's cursive. Then the a plus l's on the left cancel, and you're left with 2s over a plus l. So I'm going to write my answer. I'm going to use the symmetric property. N is equal to 2s over a plus l. But how are you going to deal with your restrictions? What do you set not equal to 0? Yeah, so we've got a plus l does not equal 0. Solve it for a. If you solved it for l, that's fine. You could solve it for a or l. I just tend to solve it for the first letter. So if you're going to solve it for a, what do? Subtract l. And you get a does not equal what? Negative l. So again, the only way for the denominator to become 0 is if a and l are the same number but opposite signs. All right, so flip it to the back. And we're going to look at 14. This time we're solving for v. The problem with v is it's stuck in a what? It's stuck in a fraction. So we need to get rid of the fraction. But again, think about the very first problem that we did, number 3. Number 3 is very similar to this. You have a non-fraction on the left, but you have a fraction on the right. Even though it's a complicated fraction. What should I do first? Even before I multiply, what should I do? What do we do in number 3 first? Yeah, we put the side that wasn't a fraction over 1. So if I were you, I would put a over 1. Haven't I created this proportion? If you can create a proportion, you can immediately get rid of your fractions. And so how do we get rid of fractions? Cross multiply.
We have to do it.
No. You could instead multiply both sides by t, but it's harder for some kids. And so since I'm solving for v, I'm going to put 1 times v minus u is just v minus u. Be careful with your v's and u's because to me they could look alike. And since I'm grading your papers, you want to make sure that I clearly understand the difference between your v and your u. And then I've got a times t, which is at. You should be making your t's curly because otherwise they look like a plus sign. So since I'm solving for v, what do I do to get v by itself? Add u. And you can add u in front of the at or behind the at, it doesn't matter. So v is equal to at plus u or u plus at. Either one is fine. Are there any restrictions on this problem? There's no fraction, right? On this one there's a restriction. What's the restriction on this one? T cannot equal 0, right? Because that's the denominator of that fraction. But when we look at this particular formula, how we've manipulated this one, there's no restrictions on this one. Alright, so let's look at 16. They're going to start to successively get much more difficult. What do you recognize 16 as? It's a Celsius and Fahrenheit conversion, right? I want to solve for F because maybe I always have Celsius and I want to convert to Fahrenheit. So I wouldn't want to always have to use my algebra. So F is imprisoned in parentheses, right? There's a couple of ways that you could solve this. One way would be to get rid of the fraction that's in front of the parentheses, right? The whole fraction. And then if you have nothing in front of the parentheses, is there any reason for the parentheses? Nope. Or you could distribute the 5/9, but does 9 go into 32? No. You're going to be left with an ugly fraction. So if you don't want to deal with fractions much, if I were you, this time it's different though, because I want to get rid of the entire fraction, not just the denominator. So if I want to get rid of this entire fraction, what do I have to multiply it by? This time I do multiply by the reciprocal, 9 over 5. Because I want to get rid of both the numerator and the denominator. I don't want anything in front of the parentheses. Because if what I'm trying to solve for is inside those parentheses, I want to have nothing in front. And if it's a fraction, I don't want to distribute. So I have to do that to the left. So I end up with a 9/5 c. So I'm going to keep c out of that fraction. Equals the 9's and the 5's on the right cancel. And I just have an f minus 32. I drop the parentheses because there's nothing in front of it but a 1. Now how do you solve for f? Just add 32. And you can add that 32 in front of the c term or behind, it doesn't matter. So I have f equals 9/5 c plus 32. And if you're familiar with the Fahrenheit conversion formula, that is what it looks like. Are there any restrictions? Are there any variables in a denominator? C is technically in the numerator, isn't it? So there's no restrictions on that one. Alright, so then look all the way down at 22. So for 22, what's different about 22? Well, what I'm solving for is in parentheses, right? So it is imprisoned, but there's nothing in front of the parentheses, right? But why are there parentheses then? There's something behind the parentheses. And later on, you'll recognize that this is a formula that we're going to be using And you'll see why later. Because this d is not a fraction, we are going to go ahead and distribute it into the parentheses. The reason why I didn't distribute the fraction in front of the parentheses in number 16 was because it's a fraction. So if you have a fraction, I wouldn't distribute it if I were you. This is not a fraction, so I'm going to go ahead and distribute it. So I have, this is an L, so make it cursive. A plus, what's n times d? I'm going to write it alphabetically, dn. Typically that's what we'll do. And then d times a negative 1 is a minus d. What are you solving for? N. So this is the only term that has n in it. I want it by itself. So I need to get rid of the a and the minus d. How do I get rid of the a? Subtract a, subtract a. So I have L minus a equals dn minus d. Again, I want this by itself. How do you get rid of minus d? Add d. You could have done that in one step if you wanted to. You could have subtracted a and added d at the same time, but for some of you that's going to confuse you. So I didn't. So now I have, I'm going to use the symmetric property, dn is equal to, and over here I have L minus a plus d. You can have those in whatever order you want to, so long as the a remains negative. So I'm solving for what again? D or n? N. Yeah, I keep asking you that because we tend to forget what we're solving for. So I'm solving for n. So what's happening between d and n? Multiplying. So I've got to divide by d. So I'm going to divide this whole thing by d. So n is equal to L minus a plus d all over d. How come I can't cancel this d here? But why? I can't cancel something in the denominator with only one thing in the numerator when there's addition and subtraction going on. So if there's addition and subtraction going on here, I'd have to be able to cancel it to here, here, and here. Because remember, technically this is L over D minus A over D plus D over D, right? And so only the D over D would cancel and become 1. The rest of that, if you did that, you'd have to leave it as L over D minus A over D. So I wouldn't suggest you do that. I would just leave it this way. It's a lot simpler. Are there any restrictions? Yes, why? Yeah, there's a D in the denominator, and what can D not equal? 0. Single variable does not equal 0. Last two. So we're going to go to 25. Oh, I'm sorry, 23. Let me do 23. What are we solving for? This is about as difficult as they get. Why? D is in a denominator and it's being subtracted in the denominator, right? So I need to break this apart. I need to break the fraction apart to get the D out of there. How do I do that? We've done this in two questions already before. You have a non-fraction on the left, you have a fraction on the right. Yeah. Put the F over 1, right? Create a proportion. So then I'm going to cross multiply here. Alright, so I've got, because I'm solving for D, I'm going to put the D on the left. So I've got F times little f plus little g minus little d equals 1 times fg equals fg. Now question.
Little f and
Big F are two different F's. They might as well be F and P for all you care. They are completely different from each other. So that's why it's important that you keep the lowercase and the uppercase differentiated. So I'm solving for D. Isn't it imprisoned? Do I have a fraction out in front? No. So if I were you, I would distribute the capital F into everything. Capital F little f plus capital F little g minus capital F little d equals fg. What am I solving for? D. This is the only term with a D in it, right? How do I get rid of these two terms? Well, they're being added, right? So I want to subtract, no division, right? Would it upset you if I did them both at the same time? Whatever I do to the left, and if you don't like that, then you can split it up and do it separately. I'm going to do the right, so I'm going to subtract big F, little g. I feel like I'm in a Dr. Seuss's story. Big F, little f, what rhymes with F? Alright, so so I have a negative, because this is negative, right? I have a negative capital FD equals little fg, big F, little g. I'm still solving for what? D. Ignore everything on the right. What's happening to D and negative F? Multiplying. So I'm going to divide by negative F, divide by negative F. So D is equal to, we're almost done, right? I don't care what you do with the negative. Now, in my answers online, there's probably two different answers. You could leave the negative in the denominator, or if you push it up to the numerator, you have to distribute it to everything in the numerator. So if I were you, I would just leave alone. Little f, little g, minus big F, little f, minus big F, little g, all over a negative big F. That's really your answer. Now, if you take that negative and you want to push it up top, you have to multiply it to everything up there. So you would have a negative fg, a positive ff, and a positive fg all over a positive f. That's an alternative solution. Are there any restrictions? You won't say negative f, you'll just say f, right? Because it doesn't matter that f is negative. What value could f be that would make the denominator 0? Take the negative out of it. What value of f would make the denominator 0? 0. Is there any difference between negative 0 and 0? So you see why I'm saying it's just f cannot equal 0? So there's your restriction. And then also on this one, if you wanted to split them into separate fractions, you could do that. You're going to end up with a fraction here because the big F and the little f don't cancel. But here, wouldn't you be left with a positive little f? Wouldn't the f's cancel and the negatives would cancel? And over here, would the negatives and the big F's cancel? Wouldn't you be left with a G? You could choose to do that. That's another alternative solution. Last problem, 25. What am I solving for? N. N's in a what? A fraction. How have you learned how to deal with a fraction? Left side's not a fraction, right side is. Make it into proportion. What's over 1?
A.
The A is over 1. Good. So then we're going to cross multiply, right? Because I'm solving for N, I'm going to end up with an N on both sides, won't I? I'm going to have 180 times N minus 2, because that's 1 times 180 times N minus 2 equals A times N. So AN. So here's the deal. You've got two N's. This N here is in jail also, isn't it? It's in prison. So do I have a fraction out in front? No. Because it's a no, I'm going to distribute the 180 into the parentheses. So I get 180N minus 360 equals AN. Because I need all terms that have an N in it, since that's what I'm solving for on one side together, I need to get the AN over here, right, on the left, or I could just get the 180N on the right. It doesn't matter. Because I'm trying to avoid negatives, I'm going to move the AN to the left, and what does that mean I have to do with the 360? Add 360 also. So I'm going to start with the AN, I'm going to subtract the AN, subtract the AN. So then that leaves me with 180N minus AN minus 360. What's left on the right? Everything cancels out. What's left? 0, right? Nothing's there, so I have 0 as a place value holder. These are the two I'm solving for. how do I get rid of the negative 360? Add it. So add 360, add 360. So I have 180n minus an equals 360. Now here's the part that's difficult, and this is truly probably one of the two most difficult problems on the page. These are not like terms, are they? Don't the terms have something in common? In n. Can't you do the reverse distributive property? Can't we factor out, divide that by an n and divide that by an n and put that out in front? What happens when I do that? What's 180n divided by n? 180. Minus, what happens here? The n's cancel, what do you get? In a. Equals 360. Now don't I have the n out in front, it's no longer in prison? And just redistribute the n in your mind. I promise you, you get the same thing. What's n times 180? 180n. What's n times a? an. So didn't that give us the same answer? So note to self, right here, we factored out an n because they had them in common, right? If the variable that you're solving for is in more than one term, factor it out of all of those terms and put what's left in parentheses. Now, from solving for n, it's being multiplied to 180 minus a. How do you undo multiplication? How? Division. So I'm going to divide this, I'm running out of room, by 180 minus a. So don't the 180 minus a's cancel? So we're going to run into this problem over here. Sorry. And so I get n equals 360 over 180 minus a. So that's my final answer. Now, is there a restriction? Do you have a variable in the denominator? Yes. Logically think about this. 180 minus what value will create 0? So a cannot equal what? 180. And if you set this equal to 0 and added a, wouldn't you get a? 180 cannot equal a. So these are going to be your toughest, these four right here. But I want you to struggle with some of them on purpose. All right, any questions? You're welcome. Any questions before I let you work on this?